Hey guys, we're going to look at vectors today. So to introduce vectors to you, vectors are some quantity with a magnitude. A magnitude means size, so as size, orientation, and direction. So we are going to look at how you denote something to be a vector. You're going to have a lowercase letter with an arrow on the top. That shows us that we have a direction to go in. Okay. If you have the absolute value bars around your vector, that means we're finding the magnitude. Magnitude, like we said earlier, is the size. And then theta is the symbol. That means that's our orientation or the angle that our vector creates. There are 3 different ways that you can write a vector. This is our notation to define one, but as far as actually giving a specific coordinate, we can have a coordinate point. We can use a complex number, so a plus bi is another way. Or we can use a matrix. So it could be a 2x1 matrix. Your book will use the words complex and Cartesian, so that's what they mean when they're talking about those 2 things. So our goal is to graph vector z with the endpoints of the origin and then 5, 7. So we're going to graph it on just a regular xy coordinate plane. This is still our x, so I go over 5 and then up 7. We have to write an arrow on that vector, though, to show that it's going in that direction. So here's our starting point, here's our ending point, but it's going in that northeast direction. So if they ask you to write it as a complex number, you would label this as, or you would write it as 5 plus 7i. The y value is what always gets that I on it. And as a coordinate matrix, the x goes on top and the y goes on the denominator, or not denominator, the bottom row. Okay, if we're asked to find the orientation, find that little angle right there. You can envision that this vector creates a triangle with the x-axis. So something that looks similar to that. And we're trying to find that theta, or that angle. So we have this angle and we have the opposite side and we have the adjacent side. And if you think back to your trig equations, opposite and adjacent are tangent, SOHCAHTOA. TOA. So we're going to find the inverse tangent, and this is on your calculator. Inverse tangent of 7 over 5 will give you that angle measurement of 54.46. When we have vectors, we can also add and subtract them. So we can use those matrices and go ahead and add vectors just like we would add regular matrices. Okay, you can subtract in the same way, I just didn't write that. You can also, if it's written in that complex number system, you can add your like parts. So A and C would get added together and your B and your D would get added together. That I just stays as an I. It's like a variable. Okay. Again, same thing. You can subtract those, no problem. So here's an example. I have the solid lines are the 2 vectors that we're needing to add. So we're needing to add 1, 3, and 2, 1. So if you write them as matrices, you have 1, 3, 2, 1 gives you 3, 4, which I went ahead and drew in as well. Okay. If you can envision, and you can sketch this on there, if you were to take 2, 1 and add this 1, 3 matrix, or this 1, 3 vector, imagine sliding that vector to the top, to that endpoint. So I slide this over here. That gives me that resultant vector, 3, 4. Your book does a good job showing a picture of that too. When we multiply vectors, we call it the dot product. So we're going to take our first vector and we're going to make it a horizontal vector, horizontal matrix, as opposed to a vertical one. So we can take our first vector times our second vector. What we do is just multiply your x's and then add the product of your y's. So x1 times x2 plus y1 times y2. So here, find the dot product of a and b. Well, I'm going to take 3, 7 and 5, 3. 3 times 5 is 15. 7 times 3 is 21. So my dot product would be 36. And finally, we've talked about magnitude of a vector, meaning the size. We're going to always find that size from the origin. So we're going to use a distance formula to find the size or the length of our vector. So if I have vector A and I want to find the magnitude, the distance formula is applied, but we would, our second point would be 0, 0. So we technically have x1 minus 0 squared plus y1 minus 0, but obviously the minus 0 doesn't matter. So our magnitude is just our x squared plus our y squared. So here if we find the magnitude of vector A, I should have an arrow over that A, my apologies. Our magnitude would be square root of 7 squared plus 2 squared. Simplify that to be 49 plus 4 to give you our magnitude being the square root of 53.